In this video, we're looking at what types of circuits can be made with a battery and light bulbs. And when we draw circuits, we don't draw an actual visualization of what it looks like. Instead, we use symbols to make it a little bit easier to draw them. We call these different drawings schematics. And so the symbols that we give are supposed to be, they're meant to be very, very easy to draw. For like a battery, per se, we draw two parallel lines, a long and a short. The long line is meant to represent a positive terminal of the battery, whereas the short line is used to measure or represent that it is a negative terminal. For a light bulb, we draw a circle, which is supposed to represent the outer casing of the light bulb, the glass part. Then we draw a squiggly line in the middle, and that's supposed to represent the filament within the light bulb, that piece of metal that glows as it gets hot. A resistor is measured by, or is represented by a jagged line. It's supposed to represent like speed bumps, to slow something down, because that's what a resistor does. It slows or prevents the electrons from moving. When we draw a picture here, this is a simple picture of a battery connected to a single light bulb. We draw the wires always in a box shape because it's easier then to visualize or to follow the schematic when building that design, when building that drawing. So here we have a single light bulb connected on either side to our battery. This, remember, is the positive, and this is the negative terminal. Now, as we connect these, we have really two types of circuits per se. We have a closed circuit, and in a closed circuit, there is a pathway from the device, such as the light bulb, directly to the battery. Whenever you have both sides of a light bulb in contact, or whenever you have each side of a light bulb in contact with a different terminal of the battery, then the light bulb is going to light up. So in this situation, we have the left side of the light bulb connected to the positive terminal, and the right side of the light bulb connected to the negative terminal. And as long as one side touches the positive, the other side touches the negative, the light bulb will light up, and we call this a closed circuit. However, if we have a gap in the circuit, then we consider it to be an open circuit. Now, in this situation, the electrons cannot make the jump here. This is representing a switch. The electrons cannot make the jump, and therefore both sides don't touch the battery. Although the left side touches the positive terminal, the right side does not touch the negative, and therefore it does not light up. Now, this is the issue if we have just a single light bulb, but what happens if we have multiple light bulbs? Well, there's different ways of connecting multiple light bulbs. The first method is to set them up in what we call series. In a series circuit, we have one loop, one path, and all the light bulbs are within that one path. What happens in a series circuit is if we remove one of those light bulbs, the other light bulbs go out, because we see here that with this light bulb here, the top part does not touch the positive terminal, although the left part does touch the negative, because it does go through this light bulb and touch the negative. The top part does not touch the positive, and therefore it does not light up. Same thing is true with this light bulb here. Although the left side touches the negative, the right side does not have contact with the positive. There's a gap here. So when we remove one of the light bulbs, it makes an open circuit, and therefore, since it makes an open circuit, the other light bulbs don't light up. Now, in a series circuit, all the currents are the same. The current in this light bulb, this light bulb, this light bulb, and the battery are all the same amount. To give you a visual interpretation or visual analogy here, remember that electricity is caused by the flowing of these electrons. So if the electrons only have one path to flow, they must all be moving at the same speed as they go through the circuit, because there is only one route to take. It's like when you're driving in a car and there's only one path for your car to take, you're at the mercy of all the cars in front of you. If it's a single lane road, however fast the first car is moving is roughly how fast the cars are moving before it. So all the currents are the same in a series circuit. One way to remember that idea is that in a series circuit, series has the letter I in it. In a series circuit, all the I's are the same. Now, one of these ideas we're going to talk about, the first thing we're going to do is we're going to calculate something called the total resistance, also referred to as the equivalent resistance. So if we want to find the total or equivalent resistance of these three light bulbs, all we have to do is add them all together. So if this is 3 ohms, and this light bulb is 4 ohms, and this light bulb is 5 ohms, in order to get the equivalent or total resistance, we simply add those three numbers together, and that is the total resistance of the entire circuit. In this video, what I'd like to do is actually solve a few series circuits, and then in the next video, we'll solve a few circuits when they're in a different arrangement. So when we are solving a series circuit, the first thing we're going to do is solve for the total resistance. To get the total resistance, that is the resistance at the battery, we are going to add the resistors together. We have 2 and we have a 4, and that gives us a total of 6. So the total resistance is 6 ohms. That is the resistance at the battery. Then what we do is we solve for the current at the battery. To do that, we're going to use our Ohm's law. As seen here, because I know the voltage and the resistance, I'm going to divide them to get my current. So for the battery here, I'm going to take 6 divided by 6, the voltage over the resistance. I'm going to get an answer of 1 ampere for my current. In a series circuit, all the I's are the same. So if this I is 1, all of the I's are going to be 1 ampere. Once I know 2 values, I'm going to solve for the third using my Ohm's law. I know I and R, so I'm going to multiply them to get my V. Same thing here, I know my I and R, so I'm going to multiply them to get my V. And once we solve for V, I, and R, then we're all finished. Let's try another one together, and then I'm going to have you do a couple on your own. The first thing we do is we solve for the total resistance by adding the resistances together. So here we have 6 plus 4, which is 10. The total resistance is 10 ohms. The next thing we do is we use our Ohm's law and solve for the current. We have 12 for the V and 10 for the R. We're going to divide them to solve for I. And we get 1.2 amperes. Now remember, in a series circuit, all of the I's are the same. So if this is 1.2, they're all 1.2. Once you know two of the values, you're going to solve for the third using Ohm's law. Here we know I and R, so we're going to multiply. Same thing here, we know I and R, so we are going to multiply to get the voltage. I want you to try this next one on your own. I want you to pause the video, try to solve it, and once you're ready, I want you to unpause and see how well you did. Welcome back. We're first going to get the total resistance, which is 10 plus 8 gives us 18. Then we're going to get the currents by dividing 24 and 18, and this gives us 1.33. Since it is a series circuit, all of the I's are the same, so these are also 1.33. And then to get the two voltages, we're going to multiply I and R. I'd like you to try this last problem again. Try it on your own, pause the video and try it. Once you're ready, unpause it and see how well you did. Okay, in this one, we're going to again solve for the total resistance. We have 3 plus 5 gives us 8. Then we're going to solve for the current using Ohm's law. We're going to divide the voltage and resistance. 10 over 8 gives us 1.25 amperes. In a series circuit, all the I's are the same, so they are all 1.25 amperes. Then we finally solve for the voltages using our Ohm's law. We're going to multiply the I and the R together. This gives us 3.75 for the first resistor. And for the second resistor, this gives us 6.25. Now in this next video, we're going to then learn how to solve for these circuits if we're given a different type of circuit. In other words, if we arrange the light bulbs or resistors in a different orientation.